Hi everyone. Good day. I'm your host Jay, and welcome to today's training sessions. And today's training sessions is about the SNA EU 12 kilowatts installation introduction. I will record today's training and we will upload it to our YouTube channel. And you can also ask for the uh, contact sales for the videos and the training documents. During the training, feel free to send any questions to the meeting chat, and I will review and answer them at the end of the meeting. Also, we will have a Q&A at the end of the meeting as well, and you can turn on your mic. We can communicate directly. Okay, let's begin today's training. So firstly, the training topic is SNA EU 12K, and I think you have already familiar with these models. But okay. And today's training topics is about four contents. Firstly, pre-installation and site assessment. Second, the installation and the wiring. The third one is a startup and some basic configurations through the LCD. The last one is the troubleshooting. Firstly, the pre-installation and the site assessment before the installation. First of all, we need to know some basics about the inverter, the SNA 12K. It's one off-grid energy storage inverter, which is applicable for different working modes, and it is equipped with a separate GIN port and a load port and a smart load port. And after install the Wi-Fi dongle, it supports remote monitoring, setting, firmware update, and we have a website on PC and app for both iOS and Android system. Normally based on the installation site and customer need, we can design the whole system in advance, like what battery we will use and the solar panels installation, the system wiring diagrams. Okay, so after that, let's take a closer look at the inverter itself. From the right side, there is a PV switch, the power on and off switch, and in the front side, there is a LCD display, the status indicator, the function buttons. And we have the battery breakers and the battery terminals here, the communication ports here, the smart load terminals, both of them came with the breaker. And the GIN terminals, the grid terminals, also the earthing terminals, the PV terminals here, two MPPT, which MPPT supports two strings. And on the left side, there is the Wi-Fi dongle, the EPS on-off switch. And also there is 4 fans installed on the side of the SNA 12K. And as for the communication ports, we have one for the CT, one for battery, both CAN and RS485, two parallel communication ports, and the dry contact port for example, the generator start function. And this one is also used in the parallel system switch. Okay, so we have learned about some basics of the SNA 12K. Now we need to choose a suitable installation site. Since the IP rating of SNA 12K is IP20, so we have to avoid the high salt and the humidity environment. So installation in such areas can hasten corrosion, and if we install the inverter in a dusty environment, we have to install a dust-proof net, and the regular cleaning is also required for heat dissipation and the regular operation of the inverter. And we have to consider the additional lightning protection. So normally the SNA 12K is equipped with built-in Type 3 lightning protection, but for the regions like prone to thunderstorms, additional lightning protection is advisable, like to reduce the risk of damage from lightning strikes. And as for the installation position and the requirements, firstly, we have to leave enough space for the heat dissipation, for example, 500 millimeters from the wall or other inverters. And we have to install the inverter upright to a vertical surface to avoid it from falling. And as for the uh, safety precautions, like safety is always the most important thing during the installation. And I will not go through that, like all of them one by one. But before the installation, I strongly suggest the installation person to read it carefully. And we also have it included in our user manuals and the safety notes on the inverter itself. So you can like read it here. Okay, I will go to the next part. Uh, now we like before the installation, we also have to we have to prepare not only the cables and breakers, but also the tools. So you can refer to the following recommendations to prepare your own installation toolkit, like based on the actual installation cases. For example, some important parts here, like isolation protection, like gloves and shoes, and also the multimeter for to check if the, like for example, the batteries, the solar panels is within the right uh voltage range, etc. Okay, and also we need to prepare the cables and breakers in advance before the installation. Okay, now we have finished all the preparation. Let's move on to the installation here. The first step is open box. We need to like check the units and all the accessories, make sure that they are all intact and nothing is missing. For example, the wall mounting kits, brackets, the screws, and the wall mounting templates here, and the Wi-Fi dongles, the CTs, and all the screws we need to install the inverters. And you may notice that there is some knockout on the side of the inverter, on the bottom of the inverters. So before the before we connecting the wires, we have to remove the knockouts. So you can either remove it, like for example, put it like when you take out from the box, or you can remove it after you install it on the wall. And you can follow the steps here to remove the knockout, and make sure to seal it after the cable connection to make sure that no dust, water, like bugs, some to entering through the holes. Oh, okay. Now let's start to mount the inverter. Normally, we can install the inverter on a brick or concrete wall, and follow the steps to drill the holes here, to insert the expansion screws to install the mounting bracket. Install the mounting bracket and fasten it with the screws and lift the SNA to the wall mount. Since the SNA 12K is weighted more than like 40 kilograms, so like we need at least two people to lift it. Once we put it on the wall, we need to fasten the inverter by install the fixing clips here, using it as a positioning plate to drill holes and install it to the inverter, then to the wall. And before wiring, remember to install the dongles and remove the front cover and the knockout. Okay, so before the cable wiring, let's take a look at the system wiring again. We have stressed that when the inverter working in the bypass mode and charging the battery at the same time, the current goes through the grid side will be at maximum level. So we need to ensure that the maximum nominal current of the AC input cables and the breaker is at least 100 amperes here, for example, for the breaker one and for the grid cables here. And as for other cables, you can refer to the cable gauges here and the cable gauges here, and also we mentioned it in our user manual as well. As for the battery, sorry. Sorry about that. As for the battery connection, firstly, for a single inverter, the maximum charging and discharging current is 250 amperes. And if any external breakers is required, we recommend choosing like 300 ampere and 80 volt switch to ensure the battery system's requirements are met. For example, if your battery don't have a switch on, so you might need to install the external breakers. And we have both CAN and RS485 communication supported. So we have to connect the cable between the inverter and the battery. So if you don't have the cable came with the manufacturer, please make sure please make the cables according to the pin definition, and I will talk about the pin definition later. And when using for example, the built-in switches of the batteries, we do not recommend you to like turn off the individual batteries to prevent overcurrent when the battery is in like high power charging or discharging. And for the battery communication, firstly, let's look at the pin definition of the SNA 12K. As you can see, pin 1 and pin 2 is for RS485, and pin 4 and pin 5 is for the CAN communication. So we have different battery codes as well for different battery brands. For example, the Hana battery is battery code 1, LuxPower battery is battery code 6, and all of them is using the CAN protocols with pins with pin 4 and 5, which is the same with the inverter. So we can just use pass-through cables to connect between the inverters and the batteries. And if the pin definition of the battery is different from the SNA, we might need to rearrange the cable to ensure the communication. And now let's move on to the PV connection. So our PV connection, firstly, we support a DC power supply mode, which is suitable for lab testing applications. Just ensure the maximum input voltage is below 480 volts DC. And when we install the PV panels, make sure that the terminals of the panels must not be grounded and do not use the common PV string input between different devices. Also ensure good insulation and keep PV input lines dry. We support two different ways of string input, identical string input and independent string input. So as for the identical string inputs, which is applicable when the number and the orientation of the panels in each string are consistent, and the string input is like the voltage is below 480 volts. The MPP voltage is recommended below 385 voltage, and the maximum current does not exceed 17.5 amperes per string. And since each MPPT have two strings, which means there is 35 amperes per MPPT. And considering that the maximum input power of each MPPT is already 12 kilowatt, so it has been 2 times of the AC output power. So we do not recommend to consider a higher PV power input. And also the thing with the identical string input, and the difference is that independent string input has a is more universally applicable. We can have different numbers of panels connect to, like, each MPPT can have different numbers of panels connect to them. Okay, and how to choose panels is also very important. We need to take the PVA parameters of the inverters and the solar panels parameters, the installation site, the environment temperatures into consideration. In today's case, let's assume that the whole system is working in the standard test condition, the STC, on the solar panels. And as for the parameters of the solar panels, we have a 250 watt maximum power, 38 maximum power voltage, 8 amperes maximum power current. And then we can calculate how many solar panels we can connect in series per string, like firstly. So, and as you can see here, the maximum PV input voltage is 480 volts divided by 38, which means 12 pieces. 12 pieces here. So which means that we can connect 12 pieces in series per string, just by the voltage here. And if the installation sites have a large temperature difference here, so we also need to take the temperature coefficient into consideration. And now let's look at how many strings we can parallel. As we mentioned, the maximum PV input current is 35 amperes per MPPT. So we can divide 35 divided by 8, so which means we can parallel 4 strings per MPPT, and take the maximum power into consideration, which is 12 kilowatt divided by 250, which means 48 pieces. So in this case, we can connect 4 strings and 12 panels. Each string is suggested for per MPPT. Not about the AC side. So before making the AC input connection, be sure to open the DC protectors and or disconnect them first, and remove the insulation sleeves for 10 millimeters here. Just 10 millimeters will be enough for the conductors. And insert the AC input wires according to the polarity indicated on the terminal box here, L and N, and tighten the terminal screws make sure to connect the PV protective connector first here, and make sure the wires are securely connected. And as for the EPS load port, the maximum output power is 12 kilowatts, and the overload ability is 1.1 rated capacity for 10 seconds, 1.5 and 2 times the rated power for 5 seconds. And if it exceeds the time range, the load connection will be cut off. As for the generator, we support two ways to start the generator, remote start or manual start. For example, remote starts, we have to connect the dry contact gym ports to the generator remote start ports. Sorry. And when there is power out, and so we can like use the gym port to start the generator remotely. For example, when there is power outage, the battery SOC is lower than the generator start SOC, then the dry contact will be turned on to start the generator and to for example to charge the battery and to support the house to supply power to the load. And when the grid power is returns, the dry contact will be turned off and the generator will be turned off automatically. Just wait a minute. And as for the manual start, when the like for example, when the generator cannot be operate remotely cannot be operated through the dry contact ports, we have to manually shut down or turn on the generator when there is grid power outage. Okay. And then that's a sequence here, which is the thing. Just when there is power outage, we have to manually turn on the generator, and when the grid power is back, we have to manually shut down the generator here. And we mentioned before in the interface introduction that we have a smart load ports, which is different from our other models that we have used the GIN port as both generator input and the smart load and the AC couple function. But for the SNA 12K, we have a separate smart load port. So through this port, we can also like achieve the smart load function, the AC coupling function. And for example, the smart load function, we can redirect the excess solar energy to power non-essential loads such as the water heaters, thereby improving overall power efficiency. And the output capacity of the smart load will be limited to 12 kilowatt along with the output power of the grid cell and the loads. So which means that the total output power of the three ports will be limited to 12 kilowatt. And as for the AC coupling function, so we support the AC coupling connection with existing on-grid solar systems, and the existing solar system needs to be connected to the smart load ports instead of the GIN ports like the other models. And when the smart load port is occupied by the existing on-grid inverters, we cannot use the smart load function anymore. So we have to choose either smart load or AC coupling function. Okay, let's move on to the next part. The Earth connection. So we have mentioned it multiple times, like the PV and the in the safety precautions, because it's very important. The ground cable shall be connected to ground plate on the grid side, and this will protect the electro. It will prevent the electro shock if the original protective conductor fails. As you can see here, we are connecting the PV to the grid PV here, and all the other loads, smart loads, house load, and the generator, all of them to the PV plates. And related to the Earth connection, there is the NPE function. This is there is one like external, sorry, there is one internal, the neutral grounding bond. So for example, it can prevent electrical shorts and ensure the device casing is safe during the faults, and to provide a low impedance path, allowing quick fault current return and triggering protective devices to disconnect power swiftly. And we don't need like So using this function, we can like simplify the installation, like no external MPE bond needs, simplify installation and reduce the cost by like emulating separate N lines grounding on the EPS side. Also ensures the consistent and reliable grounding, avoiding issues from like poor contact or connection errors. We can set this MPE function through our LCD, also through our app, and the website as well. Okay, now let's for the parallel connection. We support both like single and three-phase parallel system, and all of these we are supporting the uh, shared battery bank. As you can see here, we can connecting all the batteries. We can connecting all the we can connecting here so that like all of the inverters can share one battery bank for like better energy management. And we have to make sure that each inverters connects to its separate solar panels. So the system cannot accept the shared PV input at any time. It will to cause damages to the inverters. And as for the exact cable wirings, I think it depends on the actual installation on site. And there is a diagram for the three-phase system. As you can see, here also we can share the batteries between inverters and cannot share the PV input. Each inverter must have their own separate PV input. And as for the three different phase, like each inverters represent their like one phase. As for example, inverter one is phase R, inverter two is phase S, and inverter three is phase T. So, and as you can see here from the diagram, RST here. And also we have two as you remember before in the interface introduction, we have two parallel communication ports here. We have to connect them between inverters. For example, inverter one connecting to inverter two, inverter one also connecting to inverter three, and inverter two is also connecting to inverter three. Okay, that's all for the installation and wiring. So when we have finished the installation, we need to turn on the battery, turn on the whole system, for example, the battery, the inverters, to check if it's running normally and and do some basic settings like grid type, and the battery brand on our inverters. So firstly, we have to start up the inverters, and afterwards we need to shut down. So there is the startup and the shutdown procedures. So firstly, we need to use the, like for example, the multimeters to check all the power input is within the right voltage range. For example, the battery, grid, and the PV solar panels. And and there is step one, turn on the battery system firstly, and then turn on the battery breakers on the SNA 12K or any external battery breakers, and turn on the power on switch. And after that, the inverter will be start. If the battery like the voltage of the battery is within the normal range, and the inverter will be powered on, and we can do some basic settings. For example, the PV input modes, like how the different string, like for example, independent string or the separate strings. Sorry. And the battery type settings, also the AC input range or AC input and output range, we can also set after we start the inverters. And then in step two, make sure the PV voltage of the string is higher than 100 voltage, which means the startup voltage, and then turn on the PV switch. After that, we can turn on the built-in load breakers and the EPS on switch, and then there will be power output on the EPS port, and we can check if the inverter works normally to supply power to the loads. And after that, make sure the inverter works normally through with PV and batteries, and then we can turn on the grid power or the generator and check if the inverter can go to the bypass or on-grid mode normally to verify the like the whole system can working normally. And after that, when we shut down the inverters, we have to make sure that there is no actual loads connecting when we disconnect the battery, the PV, and the AC input power. Okay, so the step one is turn off the grid breakers of the inverters. And step two is to switch off the load breakers and the APS on or off switch. And step three is turn off the PV breakers, the battery breakers, and the power on switch. And then the SNA inverter will be turned off. Okay, now now let's take a look at how to perform some basic settings via the LCD, because the first step after the inverter is turned on is always the LCD, because like we also have to go through the Wi-Fi setting procedures, and you have to register your account before you use our LuxPower app or the website. So the most direct way is using the LCD for some basic settings. So let's first one is the introduction of the LCD homepage. As you can see here, we have 7 different sections. The first one is the date at the time of the current uh, uh, date of time of the inverters. And second one is the solar voltage and power generation. Third one is the battery SOC voltage and charging or discharging power. And the fourth one is the APS load outputs, frequency, voltage, and power. The fifth one is the on-grid load consumption data. So as this page is just an example, and for the actual application, when there is grid connected, the load consumption will show here, and when there is no grid, when the inverter is working in an off-grid mode, the load data will be shown here in the APS section. And the sixth one is the grid and the generator information. So if you are connecting to the grid, it will show the grid, and if you are connecting to a generator, it will the icon will be changed to the generator. Also the frequency and voltage and the input or output powers. And number 7 is the working status. For example, currently it is working in like certain working mode here. Or also if there is some errors or warnings of the inverters, you can also see it here. And we have 4 buttons on the LCD. If you have like remember the introduction of the before. So I will introduce you like how to use the 4 buttons to like to set some functions. And for example, how to use it to enable the smart load function. Firstly, once we enter the inverter is turned on, we can see the home page. Now in this case, we need to press the enter button here. After we hit it, it will go to the choosing it will go to the next page of choosing either go back to the home or the power generation data or the warning or fault notice or the settings. So in this case, we need to go to the settings. So we are using the up or down buttons to go to the settings here. Okay, once we like the here, we need to also click enter again. Click enter again, and we can see here there is different settings here, and we need to find the smart loads. So if we read the user menus, we will see that the smart load function is in the discharge functions here. So we use the up and down buttons, go to the discharge, hit enter again, and we will enter the page changing functions here using up and down to change to the smart load page. Hit enter again, and we enter in the exact setting page of the smart load functions. And also in this case, you can also use up and down to choose to set different application. In this case, we just need to enable, so we don't need to use up and down in this case. So just hit enter again, and if the column turns gray, we need which means we can use up and down to choose between like if we check it, enable or disable it. So in this case, we need to enable the smart load function. So when there is when it is checked, we have to enter again, and it will say set OK. And after we set OK, you can see that the smart load is already enabled. So that's the whole procedures to like to change one settings, the whole procedure to change one settings through LCD. And about as for other functions, you can check how to set them in the user menus and go through the procedures I just introduced you. Okay, let's move on to the next page. So when we are, I will play this video and do the introduction in the meantime. So when we are on site performing the installation, we can also use the LuxPower app to do some basic setup. In this case, we need to set up the dongle to connect to your home Wi-Fi. so you can monitor it. Online. So this is the video on how to set it. You can also refer to the paper setup guide came with the dongle, and this video is also available on our YouTube channels. So once the dongle is connected to the server, and we can set the inverter remotely, and we will have finished the installation on site. So even there is some, for example, some settings we didn't set right, we can also correct them through our monitoring system remotely. Okay, I think it's over about this one. So, and let's go to the last part of today's training, the troubleshooting. So there is some common installation issues we have came across before. So, and the troubleshooting. So, for example, the first one, the grounding earth fault. If the grounding or earthing have some faults, we have to verify like secure earth wire connections at the inverter and the distribution boards, and the polarity reversal to we have to verify the DC cable polarity at the inverter terminals and the source, the PV and the DC batteries. And under or over outage areas, we have to measure the actual grid voltage at the inverter terminals. Also check the if we have choose the right grid type. And as for the communication failures, which is like commonly happen with the battery or in a parallel system, we have to check the cable connections, the integrities, the terminations. Also, if we have choose the right battery brand as well. And as for the AC grid faults, we have to check the local AC breakers or the fuses and verify grid parameters, also stable and within limits. And if we cannot turn on the inverters, we cannot power on the inverters, or there is no output, we have to confirm all the relevant DC and AC breaker switches, also the switch on the inverters, like on side of the inverters, the power on and the EPS switches. And the overheating warnings, well, have to make sure that there is adequate clearance around the inverters for the ventilation. And about other errors and warning codes you see on the inverter LCD or on your app, you have to refer to the user manuals for the detailed troubleshootings. Also, you can contact our tech support team. Okay, so thank you for joining us for today's training. So I will firstly I will review the questions you send in the group chat, and you can also turn on your mic if you have any questions here about the training or any suggestions. Okay, so I have to join the meeting. Yeah, okay. You are mentioning that you are need this app, and of course we will send the app. How joined? What's in size of the battery disconnection for? Okay, we have checked the size of the battery disconnected. 20 kilowatt battery. For the SNA 12K, the maximum charging and discharging current is both of them is 250 current. I am Is that the answer you are looking for? And we will send the PPT through our WhatsApp group. Okay, and see if there is any other questions. Freelance solar design installation. How about real warranty and after sales service? So the SNA 12K is about the warranty or an after sales service. So firstly, the SNA 12K is 2 years warrant. The standard warranty of the NSA 12K is 2 year, and normally we conduct our after sales service online through our monitoring systems. And if you have some serious issues, we will also perform some on-site tech support as well. And about this question, the inverter has two MPPT with two strings each. Can you please explain how to connect one string efficiently? Let's say 12 times PV panels of. As I said before, to the in the like the panels here, so we have to examine the solar panels parameters carefully, and for example, the 400 for example divide the 12 kilowatt by the 460 watt, and you will get a rough number of how many panels you can use on this MPPT. And then you have to consider the maximum. You have to consider the maximum PV input current and the uh, maximum the PV input voltage range into consideration, and to arrange your strings. Also, if you have if you have checked our official website, we also have a calculator for this one. You just select the SNA 12K and send the parameters documents of your solar panels, then you will get a calculation result about the uh, solar panel calculation results. And about the next question? What happened? Dongles is disconnected at times. So there is multiple different scenarios when for example the dongle is disconnected. You might need to check for example your home Wi-Fi, and if it's stable or not, and also you have to check if you have set the password correctly. And as for other issues, you might need to send like your actual cases to our after sales team, and we will give you troubleshooting procedures. Also, if you have checked our website as well, we have a LuxPort AI which can answer some basic troubleshooting problems, and we will also send you some documents if you ask our LuxPort AI. About this question, how many batteries can be parallel to the SNA 12K? So mm, about if we are using the parallel, so uh, for example, oh, our the maximum charging and discharging current is 250 amperes. So you have to combine them with the battery maximum charging and discharging in parameters of the batteries. And like in series, we uh, in series there's no limits for the parallel of the how many batteries you can parallels. It is mostly depends on the battery companies. Yeah. So we just limit the whole charging and discharging current and each and if the battery have the BMS, we can limit the discharging and charging current to be 250 amperes, and then you can um, parallel the batteries based on your like capacity needs. Oh, so yeah, you are saying that the calculations. So yeah, like for example, next time we introduce the how to like calculation like how many panels we can use to connecting to one inverters. We might we can use like a whiteboard, so which will be more straightforward. And I think we will also introduce our calculator function of our website, and you can also use that function as well. Okay, the next question, if the client already has an existing GMO GM model and wants to add a SNA model, what do you suggest to be AC coupling? Should they just be separate systems with their own individual cities? Yes, so if you are using, for example, a parallel the GN and SNA cannot be parallel through to each other. So if mainly you have to like to separate these two systems. Also, you can like choose one of the models as an like existing on-grid systems, and you can use the AC coupler function to connecting one to another. And the question from Jimmy, can the inverter runs without battery during power interruption? Yes, so our inverter can run without the batteries just through PV. If the PV input is within the like for example 100 to 480 voltage range, we can run the inverter based just on PV or just on the grid without the battery. Like the traditional string inverters. And the next question, what is the surge power duration of SNA 12K? So I have wait a minute, I can share you our data sheets. Just 1 minute. Okay, as you can see here, for the surge power durations here, oh, okay. You can see here for like for example 100% to 110% to 150%, the rated power output is 10 seconds, and 1.5 and and to peak power is for 5 seconds. I think it's the surge power durations for the SN12K. The second question is, during the power interruption, can the inverter run high starting current motor? High starting current motor. So I think it depends on the actual like specifications, the parameters of the motors. So if you have and you can refer to the EPS, the UPS output parameters of the inverters to check if it's suitable to the parameters of the motors. Okay, so we are, and there is 5 minutes before we end today's training, so I will answer 2 more questions, and we also will record all the questions. Is the certifications of approved. So about the installation certificate, you can join our installer plans, and we will send you the installer certificate. So what's the role of the generator once connected to the inverter during power outage? So the generator will be will be acting as the power supplies of the whole system, and the generator can also use to charge the batteries. And the last question, please, battery compatibility. You can download the battery compatibility list from our official website. Share. Can you please share clear wirings of smart load system? So the wiring of the smart load system is also is the same with other AC output. It, it's the same, just the internals is different, as you can see here. Okay, I think that's all for today's trainings. Thank you for joining us